to the next technical session 7, Applied Meteorology, that will be chaired by Professor Dr. Taichi Hayashi and co-chaired by Mohammad Bozlur Rashid sir. So I think both of you are here, so please conduct the session. Thank you from our side.
This is Taichi Hayashi.
Yeah. This is
Okay.
Yeah.
Can you hear my voice?
Yes. Sir.
Okay. これがこれか。よいしょ。あ、これが入らない。But the camera is not available. So on the okay. So on the I will start the right. This is Taichi Hayashi. So on the Kyoto University. So I'm very happy to join the this international conference of Dhaka University. So it's time, and it is a starting time of this session. This session is applied meteorology. So and I'm a chair, and the co-chair is Dr. MD Bazil. Okay, nice to meet you. Yeah. So then we will start this session. The first presentation is Professor Dr. Wei Qing Ma.
Okay.
Are you ready?
Yeah, can you hear me?
Yes. Please start the presentation.
Okay, thanks, Chairman. I share my screen.
Yeah.
Yes. And first, I want to thank Chairman, Professor Hayashi Sensei. I remember when I studied in Kyoto University with Professor Ishikawa. Yeah, I know you very well.
Yeah.
And second, I want to thank Dr. Fatima. Yeah, because I worked in Kyoto University. We are in same laboratory. Yeah, and today I want to shortly introduce our observation system in Tibet Plateau, and also some work. For example, the heating field, how to influence the atmospheric cycle. So in order to manage the time today, I recorded my presentation. So I just play. If I have any question, I'm here. I can talk with you. So now I play. I will introduce our study work. It's about analysis on surface heating field by using different methods of the Tibet Plateau. I'm Wei Qing Ma, come from Institute of Tibet Plateau Research, Chinese Academy of Science. My colleague is Professor Yaomin Ma, and also my PhD student, Yi Zhehan. In beginning, I want to shortly introduce our group. It's land-air interaction and its climate effect. We call it NEC. My team leader is Professor Yaomin Ma. I'm the team assistant. You know, in our institute, we have 4 big groups. It's the environment change of land space process, and the other 3 groups. And my group is land interaction with climate effect here. And our next knowledge and the data production will help our institute group to understand the environmental change and the climate change process on the Tibet Plateau and the surrounding regions. And our goals is on the land atmosphere interaction and its climate effect, to clarify the change in the land-air interactions on the Tibet Plateau and its influence on the weather and the climate in the surrounding areas. And the research directions we have for it, first is the Earth's atmosphere, and second is atmosphere boundary layer process, And the third is non-aerotransfer interaction process. And the fourth is the three process under the climatic effect. This is our team member. We have 5 professors and 3 research assistants. Now, let's begin my presentation. I will divide 3 parts. Is background, our recent work, and the future plan. And this is a map of Tibet Plateau. We can see it has a high elevation here. Because it's atmospheric heating source, the west wind hits the Tibet Plateau, it changes the directions. And also from south, the warm water vapor and the cool air at the Tibet Plateau, it also changes the directions. So it's huge influence the weather and climate in China, Asia, even all over the world. And based on the situation, we set up the Tibet Observation Research Plateau. We call it TOP. This platform published in Barnes in 2008. So this is a detailed 7 IP transformed 7 observation station in Tibet Plateau. We can see from south we have the Linji, Namchuo, Lachi, Shanghu, Ali, and Chumlama. So I want to detailed introduce the first station is Chumlama station. Maybe in West we call it Mount Everest. We have a 40 meters tower. We have 5 layer observations in boundary layer, and we have turbulence system, also radio result system, wind profiler, and the GPS, and the turbulence system, and other instrument. And for the flag stations of the different space, we have the others, for example, Danxing, Namchuo, Yangdong, Lhasa, and Sterling Lake. And also have Lachi, Glassy, Machi, Grass, and Danxing wetland. And also in Nepal, we have the AC system. For the second Tibet Plateau scientific and research, also we set up many observation systems in Tibet Plateau. For example, we have weather radar and the atmospheric radar, wind profiler, AWS, wind radar, and the micro radiometer. And also we have the LAS and the PV panel. And for the floating board and the reading zone, and also have the radio aircraft and the remote sensing. And this is a map for our observation site in Tibet Plateau. The red one is our new PPL in Tibet Plateau set up in last year. And the blue one is the existing PPL. It mainly exists in different parts in Tibet Plateau. And this is a detailed new atmosphere boundary layer tower station in Tibet Plateau. And we can see English name Moto, Mangkang, Chengdu, and we called in different parts in Tibet Plateau. And for the microwave radiometer observation network, we have set up a line. Also, we want to set up another one in Yupoi called the COVID-19, and we cancel that plan. But if so, we also want to set up that. We set up the Ali, Chengdu, Chumlama, and Bush Tiger, Linji, Mangai, Nachi, Kambu, and Mount Amei. And for recent work, I wanted to, for the land space on the atmospheric heating, we want to 4 parts. Because we have so many observations, so I want to use the set observation to see some result. And for the Tibet Plateau, we're using the reanalysis data to analyze the boundary layer and land space heating. And By the way, we also use remote sensing on the Symphony, use numerical model to do some research work here. And this is a new work. In last year, we published our all observation data. It means comprehensive observation system network for multiple interaction established. We also published all of this data in ESSD. This is a paper. Yeah, our leader, Professor Yao Mingma, and this is myself. And for the land atmosphere observation network talk, and we have two stations. This means this is Chumlama. We along the road in different elevation, we set up many stations because we want to know the different layer, different meteorological element. And in Motor, it means in South Tibet, we also set up the many observations. We want to know the mountain atmosphere interactions research. And why do we this work? Because we know the atmospheric source is the driving force of the atmospheric circulation. And the Tibet Plateau have a great influence on Tibet circulation system and the climate pattern. And not research about space heating flux of the Tibet Plateau and the study on the atmospheric heating source of Tibet is insufficient. So we do this work. When I was working in Japan, and in 2013, we talked with Professor Koike, and we also talk about some heating source. And in his group, for example, Taniguchi, and published some series of paper to say the heating. But for us, we want to know some fact using our reading result data and how to do this work for detail. So what do? We want to use our advantage, for example, observations and the analysis heating process of the different parts of the Tibet Plateau, and try to connect the atmospheric source of the Tibet Plateau with extreme weather through the atmospheric circulation. And for analysis, which data we use? So here, we verify the ER interior surface sensing board and latent flux relay data from January 1979 to December 2016. And we also analyze the downward space heating of the Tibet Plateau in different months. And this is a distribution atmospheric heating source of the Tibet Plateau in different times. And we can see in April, May, June, July, August, we can see, and also September, we can see the heating source very strong. And in different seasons, it's a little, not so strong. And we're doing so many work about the land space observation and the remote sensing work in past nearly 15 years. But we also want to know some detailed process. So we use the Wolf model. This work also done in Kyoto University in DPI with Professor Ishikawa. And in that test, for me, it's also a new knowledge. So how to do this work? For here, we use the soil moisture. I think it's a very, very important parameter. And we improve the heating field. The goals is we can use our observation to know the Tibet Plateau land space fluxes. So this is what can I do? Yeah, it means we can use soil moisture, to replace the Wolf initial value to test how much effective in the model and the combine model result and its inset data. This is the model set. We have the domain 3, domain 2, and the domain 1 is covered all the Tibet Plateau. This is the detailed information. And in the first, we found the model and the observation have a big difference. So this is our our reason why we do this work. So we're using default soil moisture, temperature, vegetation coverage, and vegetation coverage in currents. So we want to know the detailed work. How about the result of the non-specific heat fluxes? And this is the result. We can say when we import the change the soil moisture, and also we enlarge the coverage. It means we can say the latent heat fluxes is really gets our observation. So it means if we change the initial soil moisture, the result should be improved. And this is the monthly result. We can say the change of daily diurnal change is very, very simply with our observations in Tibet Plateau. So when we replace the soil moisture, how to enlarge all the Tibet Plateau. So it's our main work. At that days, I worked with Professor Ishikawa. He encouraged me to do that work. It means if we do the bed method and we can do the regional heating field, then we can know the flow, field temperature, energy, and water cycles of the Tibet Plateau and the surrounding areas. And this is our options. We use the basic, for example, RTM and the morning of curve, and also Rance University scheme to the bound layer. And we just using two cases. It means case 1 and case 2. Case 1 is the default value, and case 2 we change the initial soil moisture, and this soil moisture comes from Professor Toshi Koike from University of Tokyo, and that is he sent all of the drawn data. We can say when we change the soil moisture, and our result is nearly same as our observation. This is single heat flux, and this is the latent heat flux. For the monthly value, we can say the diurnal change is also very similar as our observations. So we think when we do the experiment in the WRF model, I think we can know the detailed information about how to change of the non-heat flux using WRF model. For the remote sensing, I think we want to try to introduce our recent years in our group work. The first is our physical process effect neck impression. In past several years, our group mainly do some land-air interactions. But you know, in Tibet Plateau has many necks. So we want to know how about the neck-air interactions. And in 2020, we proposed the inert method to regional neck evaporation estimation using satellite data and obtain the accurate evaporation. And this result published in Science Advance last year. And also, this is a paper detailed, and this is myself, and this is my postdoc. Yeah. And the result and test set has been widely reported by some Chinese agency, Chinese news, and other method at net. Yeah, this is some general pictures. And in this year, we also published our result. It means the evaporation. We using the average annual evaporation. This is a general value, and also published in ESSD. And I think now I just introduced very limited result in our group and by myself. I think more about our work and not introduced here. If you're interested, you can check our website. And for future worker, I think we continue do some reanalysis data analysis and also ready zone data to use and improve the circulation at the heating field in the Tibet Plateau. And so we can access the west and the eastern part in Tibet Plateau. It means we can connect the adverse heating change of the local weather system in East Asia through the atmospheric circulation and analyze the mechanics with model. So next step, I think we can continue to the observation, for example, in situ, remote sensing, analysis data, and safer site in Tibet Plateau. It means in Tibet Plateau, now we have
Please finish your presentation.
some observation site. And how to entice all the central region, for example, Tibet Plateau and nearby surrounding area and the Panstep region. So we can, this is the Panstep and Tibet Plateau. So this is my.
Yeah, I think I should stop here. Yeah, this general introduce for all the Tibet Plateau. Yeah, thank you.
Thank you very much. The very comprehensive presentation of the Tibetan observations is very interesting. We don't have enough time, so please, very small, very short questions. One or two small, short questions from audience. No?
Please, Kurt.
Yeah.
Ah.
Yeah, very good presentation. I would like to know if any major global warming impact is observed over the Tibetan Plateau as well. It is understood that the higher altitudes warming is much higher than in the plains.
Yes, yeah. Thank you for your question. Yeah, in Tibet Plateau, you know, I remember in 1998, you know, Japan has also with our institute, Chinese Academy of Science, set up many tower AWS in Tibet Plateau. But now, in Chinese government support, we also set up some PBL tower in different landscape. Yeah, it means we want to know different landscapes meteorology element. So yeah, it's our goals.
Thank you very much. So
Okay.
we have the time is up, so we will move on the next presentation.
Okay,
next
thank you.
presentation is thank you very much, Professor Wei Chen Ma-san. The next presentation is Professor Toru Terao of Kagawa University. Please start.
Yes, thank you very much. Thank you for chairperson. And now I'd like to start my presentation. And so my title is like this. So this time I'd like to discuss about the large-scale Asian monsoon circulation and how it is set up by the heating by the atmosphere. And so this time, our colleagues, the Solomon, it is our team focusing on the northeastern part of Indian subcontinent. So we are setting up many observatory sites, and also we analyzing about the system of the Asian monsoon in summer and pre-monsoon season also included in the northeastern part of Indian subcontinent. So this is our collaborative work. And we have many collaboration with the northeastern part in the subcontinent, and one of them is the University of Dhaka. So we have very good collaboration with our university, and we have one collaborative agreement also. So we like to extend it to all that university level, and we want to continue and we want to intensify our collaboration. And also we have many collaborators in Bangladesh area, including BMD also. And so this is university only, but BMD is very important our colleague. And also in northeastern part of India also, we have many collaborators in the Assam state and also the Meghalaya state also. And also we have very large scale, ASEAN scale collaborations under the ASIAPEX, ASEAN Precipitation Experiment, just launched in 2019. We have many collaborators in the South Asia also, and TX also coming to this conference, and we have very good discussion there. And South Asian part will also be developed as a part of South Asian PEX. And we had one workshop in the Central University of Rajasthan, India, in last year. But after that, COVID-19 coming, so we have somewhat difficult time after that, but we are extending our collaboration. Today, sorry, contents of this talk is like this. So firstly, I'd like to talk about background discussion. And after that, we like to talk about the HD theme and HM theme. It is high dry static energy air mass, and this is high moist static energy air mass. We are now developing some view of the establishment of ASEAN monsoon circulation system. So we'd like to introduce some new view about that ASEAN monsoon circulation. And as you know, ASEAN monsoon is characterized by the very strong reversal of meridional temperature gradient. And the southern portion is somewhat lower temperature. To the north, we get a higher temperature here. This very interesting reversal of temperature gradient is very important aspect of the ASEAN monsoon system. And we have very strong reversal all over the ASEAN continent. And so this is one of the driving forces of the ASEAN monsoon circulation. And this is due to the very strong heating existing just south of Tibetan Plateau. So Tibetan Plateau has to be very important for this heating. And also we have so much convection in the northern part of the Bay of Bengal and northern part of India, just south of the Tibetan Plateau. These aspects have to be very important for the driving force of this circulation system of ASEAN monsoon. So I'm now very much interested in how this strong heating makes that the upper tropospheric circulation of the monsoon in the it's covering all over the Eurasian continent scale. This is somewhat old paper of mine, but after the onset of the ASEAN monsoon, this type of very strong circulation, the rotating circulation develops. And the very strong heating causes the divergence also, but the divergent part of the circulation is not so strong, but it's there, but not so strong. Maybe this is because the strong heating causes that very strong divergence, but it makes that the response by the extratropical atmosphere, it's a geostrophic adjustment, and it makes a strong anticyclonic flow over the upper portion of the troposphere, and it makes the very huge Tibetan plateau, Tibetan high all over the Eurasian continent, and it also extending to the Pacific Ocean also. So because of that, the air mass inside this very huge anticyclone is confined into this very strong anticyclone system. It can so much easily can go out from this strong anticyclone circulation. Sometimes it goes out to the south, going to the southern hemisphere. Sometimes it goes to the north with some turbulence to the stratospheric air. So like that, it is very strongly confined into this very strong anticyclone. These are very important aspects of the ASEAN monsoon circulation. And if we cut that the atmospheric pattern, the vertical distribution of potential temperature in the pressure coordinate. And this is time, 1983, one case study. But if after that onset of the monsoon, the amount of the air mass with potential temperature between the 350 to 360 Kelvin increases, and it going on 2-3 intra-seasonal variability. And these aspects indicate that the air mass coming from the bottom of the atmosphere is going up to the just below the tropopause, and this air mass is confined to this narrow potential temperature range, and it undergoes an increase and decrease like that. So now I'd like to propose another view of the circulation. Firstly, we have the high moist static energy air mass with the high equivalent potential temperature in the lower troposphere, just south of the Tibetan Plateau, and also over the Tibetan Plateau also. And these air mass have to be transported by the strong convections. It has to go to the upper portion of the troposphere, and it will be accumulated here. And because of the accumulation, the isentropic surfaces is pushed down around here, and it makes the heating of the air mass around this area. And it is a kind of cause of the large-scale temperature gradient reversal. And here is the highest temperature, and here is somewhat lower than that. So the equatorial area and the azimuth area has a very big reversal of the major temperature gradient. And clearly, we can see very strong accumulation of the high moist static energy air mass and other in the lower part of the Asian monsoon area because of this effect of mountains. This is the Booth and Kahn, and they introduce some view about how that the very strong accumulation of the high equivalent potential temperature air mass is accumulated in the lower part of troposphere. So these atoms, these high equivalent potential temperature air mass have to be transported to the upward, and it can make, only this can make the accumulation of the upper tropospheric high potential temperature air mass here. So this accumulation process has to be very important. It is our view. And here is some different view about our idea that this is tropopause, and tropopause is a kind of the radiative equilibrium is established here. So because of that, this is tropopause. And above tropopause, there is a heating. Below tropopause, we have radiative cooling, and it separated the atmosphere in the troposphere and stratosphere. And here is somewhat near to the equilibrium state or in the radiative view. And so because of that, here somewhat the temperature, potential temperature is somewhat more conservative for this area. So if once the high potential temperature air mass accumulated, after that it tends to be accumulated there. And of course, we have some coolings, so it leaks from the down part of this accumulation, but the leakage is not so strong. So because of that, we have a very strong accumulation here. And after that, the radial cooling transport air mass to the downside, and it goes to go down to the lower top part of the troposphere. And so we are now show some result about the analysis about the accumulation of high potential temperature air mass and high equivalent potential temperature in the lower troposphere. And there is some discussion from the atmospheric chemistry side. They also discussing about the very quick transport of the air mass in the just above the ground surface to the upper troposphere very quickly to the high elevated areas due to the strong convections. And there are many evidence about that strong air mass transportation from the lower troposphere to the upper troposphere, very strong, very quickly. Very quick transportation is found. But the CO or CH4 and some other different chemical tracers show that this very strong and very quick process is there. And the air mass in the lower troposphere is transported directly to the upper portion of the troposphere, like this. We are analyzing this process using the ERA5 dataset. They have very high resolution in space and also in the temporal direction also. And the hourly data with 0.25 degree longitude lattice is very nice data set to analyze this. And so we use some GSMAP also. Today, I may not have time to show this result, but we are using GSMAP data also. And we are analyzing about the mass continuity law applying for the high dry static energy air mass. It is a potential temperature with 355 to 375 Kelvin potential temperature. So this is the conservative law for this air mass with this potential temperature, and we can estimate the residual of this the conservative law using this data set like ERA5. We can get the result is R residual, and residual have to be because of that in conservative process like radiation, the convection, and some others. Maybe radiation and convection have to be very important. Convection inject the high potential temperature air mass in the upper troposphere, and the radiation have to be leak these high potential temperature air mass to the downward. So these two processes is very important for this to explain the residuals of the in conservative portion of this change. And using this method, we are analyzing about how the upper tropospheric high potential temperature air mass is accumulated and how it is coming from the lower portion of the atmosphere. And here is the high potential temperature air mass just below the tropopoles. And this is the winter, in the border winter. It is the border summer. And summer season, they have very strong accumulation in the ASEAN area. This is the kind of body of ASEAN monsoon, in my view. And so this makes that high heat up the temperature over this area, and it makes a very strong reversal of the temperature gradient here. And in the lower troposphere, we can see the high amount of high moist potential, high equivalent potential temperature air mass accumulated in the lower troposphere over the ASEAN area only. And in the winter, we have some over the this Australian area, but it is not so much. And we have a very high amount of high potential temperature air mass only in the summer monsoon, ASEAN summer monsoon season in the ASEAN area. It is very important for the ASEAN monsoon circulation setup. And here, the difference between April and July. So accumulation of high potential temperature air mass occur between this April and July. And we can see that how it increases in the time sequence. And this is April and this is May, and the former, this is the latter part of May. And during these two periods, we can have the very strong accumulation of the high potential temperature areas in the upper troposphere. And we can see that the high amount of lower tropospheric high equivalent potential temperature areas can be seen in the all over the Bay of Bengal. And it is accumulated very highly here. And because of the development of convections, maybe in the nearby, the northern portion of the Bay of Bengal and the Bengal Plain, and it makes a very strong injection of the high potential temperature areas to the upper troposphere. It's our idea. And so this very sudden increase in the upper tropospheric high potential temperature areas maybe very much related with the convection, the developing over the Bay of Bengal and the Bengal Plain. And the effect of the Tibetan Plateau may also be very important. So we analyzed about this effect, and we find some portion is very important for the accumulation after the beginning of July. And here we can see that the high equivalent potential temperature areas develops around the beginning of July, and it continues up to September. So it directly going to the upper troposphere, and it heat up the upper tropospheric air. So Tibetan Plateau may also have very important role after July. But for the beginning portion, so beginning of the Asian monsoon season, we have a very strong signal only in the Tibetan, the Bay of Bengal and Bengal Plain. So this area is very important driver for the monsoon onset.
Please, sir, finish within 2 minutes.
Yeah, sorry. This is our some result from the result, and we compared the result with the LR5, and we found in some areas like the Guwahati, the Assam Valley, that the estimation of the LR5 is very much underestimated, can be found. But for Dhaka, we can find very good relationship between the two variables estimates. So this difference is there. So that the LR5 cannot reproduce the process in the lower tropospheric accumulation of the high equivalent potential temperature air mass. So this is our summary. So now I finish. Sorry for long talk.
Thank you very much, Professor Terao. So, and it's very interesting problems, and time is up already. So, and only small questions, if possible. Do we have any questions from audience? Okay, I will move on to the next presentation. So next presentation is Dr. Ashraful Haq. It's okay? Yes,
Hi.
please start the presentation.
Thank you very much, and good afternoon, everyone, and good morning, like wherever you are locating at the moment. So this is Ashraful Haq. I'm the 4-1 Bangladesh coordinator, and this is really a very great opportunity to meet you all, especially the forecasting people, the data analysts in this conference. So my topic is very much. Let me see whether I'm sharing the right one. Can you see my screen, by the way? Can anyone?
Yes.
Yes.
Okay, carry on.
Okay, that's good. So the topic for my lecture today is data and forecasting for humanitarian action. I'm not a forecasting guy. I'm not a data analyst either. So my work is to use what you are producing, what you are doing research for years, and how to translate that kind of forecasting and data into decision making for humanitarian action. And For One Bangladesh is a staff network technical part in Bangladesh. So we are having right now around 47 national and international NGOs who are members, and we are supporting them to popularize and capacity development on anticipatory action. Probably many of you have heard about this terminology, but we'll go into that as well before I spend more time for what I actually tried to convey for today's session. Just to recap, like what actually we are working on, that disaster management and humanitarian field. So, you know, like when there is a disaster, right after that, we do response, and then we try to rehabilitate eventually, followed by reconstruction. And so when the things are getting normal, then we start to think about the disaster again for next year. And then we try to understand what are the root causes of the risk that is caused by disaster. Then we try to reduce that kind of risk that we call disaster risk reduction. And disaster risk reduction is a part of also prevention. And then you see, like, okay, there are prevention activities like structural, non-structural. Structural is kind of building the embankment. If you consider like a flood, or if you consider cyclone, probably then building infrastructure is not probably the very vulnerable materials that you're using for your house materials, house building materials, but probably very strong house building materials that you are using as a prevention. And then this is the very hard part of the measures. And then you have the soft part, like to aware people, build their capacity, when to act, how to act, and what to do, these kind of things with different layer of actors and stakeholders to act together in a very collaborative way to make a very successful preparedness program. And then then probably the hazard comes that might turn into disaster, but that's all depends on your like post-disaster situation and pre-disaster situation and preparation. So this is very normal one, and yeah, so I'm not gonna go into that very deep, but there's a relation. That's why I thought like just to present that in the beginning. And then you see like why it is so important, like when you talk about disaster, why it is so important, like to have this clear concept on disaster and development. And many times when we start talking to people in this humanitarian area, we found development practitioners are there. They also do some things which is very much relevant to disaster, but not disaster intervention. But sometimes what we do as a DRR interventions, that is very much something like to probably development, but it's not really development. But so we found like there's a overlapping something which is really interesting. And this is kind of like the graph that tells you where actually the nexus is. So where we are going through, probably due to our sustainable development goals, or the national development vision, our goal, then probably we are flowing that very curvature of development track. But when the disaster comes, it actually pulls you down. Your whole development process stops, and then you need to start again, where you don't reach the same vision as you had before due to disaster. And if you start to falling down every time that's because of disaster, then probably you never reach to the goal that is that is agreed by the global communities, that is agreed probably the national policymakers. So that's why we really need to understand the disaster and very well, so that we can also contribute to the ongoing development. So there is no like kind of time to underestimate, like okay, disaster is something different that doesn't have any connection with development. But whenever we do some sort of any kind of development plan, it should be very much simultaneously, it should be side to side consideration. Yeah. And then here is comes like, if you can just remember my second slide, I've been talking about the preparedness prevention. That's the pre-disaster activities or interventions. And here comes the traditional and the new anticipatory action paradigm. So now in the humanitarian sector, we are talking much more about being proactive rather than reactive. So our traditional response system is very much like you start your actions right after the disaster happens. And then the recent study has shown that, sorry, just a quick moment. Sorry. Yeah, and our like, so the traditional response system starts right immediately after the disaster happens. But if the recent studies have showed, even there is a study in Nepal that showed like if you spend $1 in the anticipatory time period, that can save $7 investment in the response side. That's why anticipatory action becomes very much like very much popular among the donors, and even like it has its own momentum, which gives us the anticipatory action endorsed by our government in our SOD, Standing Order on Disaster, in 2019. So when we say anticipatory action, it means we need to use the forecasting. Here comes your like part of contribution. So we consider the forecasting information, and then since the forecasting turns into a warning that has some sort of like consequences probably, then that time period and before the disaster hits, so that's the time period that we call lead time. Within that lead time, we can do something. For example, right now for flood, we do have 5 days deterministic forecasting, which gives us the time period, like 5 days of action, which could save more lives and assets if we can mobilize the resources immediately. And when we do have that 10 days probabilistic forecasting with more confidence level, and now we can see like FFWC is trying to go with the 15 days probabilistic forecasting in the future. So it would extend the lead time for us to do a lot of things that didn't happen previously. So that's why anticipatory action for every hazard, for example, like when we talk about cyclones, so probably right now 72 hours we got some sort of forecasting, but due to you people who are in this field developing the forecasting or building the accuracy of the forecasting, is amazing. We could extend the lead time, and whenever people get more time, especially the vulnerable people at the communities who are likely to be exposed, they can do a lot of things during that time. So that's the anticipatory action. And now, like, I'm not just gonna talk about the whole the disaster management phases that I talked about, but is the anticipatory action, so that you could gaze like the other phases has also the importance of the data and forecasting. So now I'll be just briefing about the what anticipatory action, why it is so important, like the data and forecasting. So I just took an example of fluvial flood here, and just to give you the sense why it is so important and where exactly it is so important to get the data. we need to have the hazard maps, and then of course like a flood forecasting warning center, do they provide that kind of flood maps? At which scale? Probably if that is generic, then we need to make it more like at micro scale, so that you know exactly that location, that union or villages are likely to be impacted due to that kind of hazard, and how much water depth could be there, what are the sectors can be impacted, how many people can be impacted. So in our risk model, what do? We need the information, we need the data of hazards, and we need the data of like the vulnerability, the people living over there, their social vulnerability, economic vulnerability, cultural vulnerability, or physical vulnerability. We need to investigate all this kind of vulnerability information, and we have to have this kind of information as well, and how much area will be exposed to that specific hazard. So I'm just considering here the flood, but this could be some other hazard like cyclone, could be landslide, could be riverbank erosion, cold wave, heat wave. Dr. Mannan has showed that heat wave things. I think you have already idea about that. So we need that kind of exposure level information where you can contribute, and where we need people to understand more at micro scale, like how exactly which unions or which villages will be impacted. So this kind of information is required there. And then there's another part is like we call that that's not only flood mapping, but also we need historical evidences of that event. For example, like, okay, if that is that 1.5 meter above the danger level, so where that impact in that particular exposure, and then you do have that kind of information together with the hydrodynamic model that FFWC right now is producing. Then considering all of these maps, historical discharge records and historical impacts together, then we got forecast flood maps. That's again for the flood hazard. And then we got that forecast impact data, because for that particular exposure, we do have the census data, we do have the vulnerability data. So bringing them together, we try to understand how much strength that hazard has to be impacted. And then what we do from our side, we just collect all this information together to design the trigger. Okay, so this is exactly, if the water goes at that level, then there is that much impact could be seen. For example, okay, so if the water goes above like 1.5 meter, then the household will be inundated. If the water goes just 1 meter above, then the arable land will be inundated. So this kind of information, we need to consider that, and we need to set the triggers and threshold, considering all this sort of data and forecasting information. And there we also talk about the confidence level, because that is very important. If you give the if the forecasting is not that much good, then mobilizing these people might give them false impression, where all the agencies like humanitarian agencies and the government agencies is very careful. So we should not work with something which has very low confidence. So where again the forecaster can play a very important role to build that kind of confidence. And then we having that flood risk profiling data, the impact data, the forecastings, then we actually take decisions where we want to mobilize the resources, how many resources is available, who are the actors should come in place, and how they can use the data. And then, of course, not only on the anticipatory side of this thing, but it has very good impact on the response side. So when you do have all this sort of data, dynamic data, because this is not like 1 year data is very good, like when you are working in that field, but what you have what you are learning that needs to be fed into next year. So we need that kind of dynamic data. And like people are dynamic, people move from one place to another. Vulnerability is also is dynamic. And so we need to have this sort of like the latest technology of forecasting as well as dynamic data set, which can give us to take a right decision on time. And what we are trying to do with this chart, like we are trying to share that kind of forecasting information with that marginalized people so that they have more confidence to monitor that kind of forecasting that could give them more confidence to take the decision where our threshold and will be revised by them and they can take the decision on time. So this is pretty much like what I wanted to convey to you. This is the anticipation side of the data and forecasting sense, but there is also response and the other side of that. Just to give you an idea how important for us to have a very accurate and precise data and dynamic data beside the very good forecasting information. So I'm stopping here. The rest of the time I would like to respond if there is any questions. Otherwise, you can reach out to us. This is ashraful.haq@startnetwork.org. And yeah, the moderator might send me if there is any questions or queries.
Yes, thank you, Ashraful. Have you finished your just time? Please start.
Oh, thank you very much, the presentation. So, any questions or comments or suggestions? No, it's okay. Okay, thank you very much. So, and if audience has some questions, please contact with personally. Thank you very much.
Thanks.
The
Bye-bye.
next presentation is Shuchi Chaki-san.
Yes, it is.
It's okay?
Yeah, it's Shuchi Chaki.
Shuchi Chaki-san, yes.
Yeah. So,
please start.
Yeah, can you, so you can, I hope you all can hear me clearly.
Yes, yes.
Has my screen gone to presentation mode? Hello?
Yes, okay, carry on.
Okay. Honorable Chair, Co-Chair, respected professors and experts, good afternoon. First of all, I would like to thank the organizing committee of International Conference on Meteorology and Climate Science and the Department of Meteorology, University of Dhaka. It's really an honor to have the opportunity to attend such a distinguished audience. My name is Shuchi Chaki and I'll be presenting my talk on development towards heat health warning system over Bangladesh. The outline of my talk is presented here. After giving a brief introduction and motivation that has instigated me to conduct this research, I will give a description about the terminologies like heat waves, heat health warning system, physiologically equivalent temperature, and then go on the methodology and explain the results obtained and some of the concludatory remarks. Now, these are the very common pictures in a third world country like Bangladesh and during the summer heat wave days. So the people living in slum and eking out their livelihoods by physical work, heat waves and summer are an extra sufferings to them. But it's not actually a problem of Bangladesh. Rather, due to the changing climate and global warming, increasing global warming, the world media is getting flooded with the lots of heat wave related news and warnings. In fact, repeated warnings have been done in Bangladesh in the last couple of years. The most important one is that Bangladesh in this year, Bangladesh records highest temperature in the 7 years amid heat wave. It is very alarming that how frequently we are breaking the records of extreme temperatures. Is like for this it is 7 years. So keeping aside these media reports, let's look at some of the scientific approaches. Now these two figures are based on the wet bulb temperature on the historical analysis. From these two pictures, you can see that some of the world's most hottest regions lie across South Asia, and Bangladesh is one of the most vulnerable countries here. Not only from the historical analysis, but also under two different emission scenarios, the indication is clearly alarming. The heat wave, the strength of heat wave is actually increasing, and the frequency is also, in the frequency of heat wave is also raising and soaring in numbers. And Bangladesh and adjoining West Bengal are one of the most vulnerable regions in this retrospect. These are not only scientific facts, we also get some of the morbidity and mortality data connecting to the heat wave that have really that has been really alarming. In fact, in South Asia, the heat wave has been ranked as the third most deadliest natural disaster. During our 8-day heat wave in 2008, over 3,800 people died from heat across Bangladesh. Now, Bangladesh being in a tropical region, so it is quite unexpected, but these statistics give us quite a strong ground to work on heat health warning system. Now, before going to that I am defining heat waves, or what the definition that I used for this study. Well, according to the World Meteorological Organization, the heat wave is the extended period of prolonged heat where the daily maximum temperature is higher than the average climatological temperature by 5 degrees Celsius. But in Bangladesh, we use the definition provided by Bangladesh Meteorological Department, where a heat wave is considered when the daily maximum temperature exceeds 36 degrees Celsius. And then the moderate and severe and very severe heat waves are defined in the are defined as follows. Like for severe heat wave, whenever the temperature crosses 40 degrees Celsius, we register it severe heat wave. Now, the heat health warning system, or to build up the heat health warning system, we must focus on the purpose of HHWS, which is actually providing meteorological and climate prediction based on the information, obviously, the likelihood of forthcoming what weather that may have an effect on human health. So whenever we're going to build up an heat health warning system, we must focus on the effects of heat health. And that's why, first of all, we need to determine the thermal stress. This leads us to the objective of our study. So here we first simulate heatwave episodes during heatwave episodes using WRF model and analyze the associated weather variables. Then we determine the thermal stress condition using PET, which is physiologically equivalent temperature. And during the pre-monsoonal heatwave events, and for this study, we have mainly chosen the 8 divisional stations as shown in the picture in the right. And then finally, we evaluate the skill of advanced research WRF in predicting thermal stress over Bangladesh so that a heat health warning system can be developed for the country. Now, there are lots of heat indices for expressing comfort, discomfort, or the term and related to heat, but we have chosen physiologically equivalent temperature. Now, physiologically equivalent temperature is the air temperature of a standardized room. Well, by standardized room, we consider this following condition where the wind speed is 0.1 meter per second and vapor pressure is 12 Pascal. And so in the standardized room where the human body experiences the same level of thermal stress resulting in the same skin and core temperature of human body as in the real outdoor environment. So the reasons for choosing PET over other indices is that it is directly related to the thermophysiological processes of human body, because the base equation of calculating PET is the heat balance equation and the Munich energy balance model for individual. Besides, it has also included the effects of long and short wave radiation, the physiological parameters like metabolism, activity, and the insulation parameter like clothing. So the given the different ranges of thermal stress indicated by PET has been shown in the figure. So where you can see that the PET value ranging from 23 to 29 may be felt as slightly warm, but it will produce slight heat stress as per the thermophysiological aspects. So for the PET value greater than 29, that would be a moderate heat stress. Now heat stress is directly linked to the chronic diseases and long-term morbidity. So for this reason, we have chosen PET as our index of developing and heat HHWS. For the methodology, here we have first simulated our heat waves using WRF model, and we have prioritized on the leading time D9 so that we can exploit the full benefits of forecasting opportunities, and then used Raman model to calculate PET values. Now, Raman model offers quite a flexibility, but for our research, we have used temperature, relative humidity, wind speed as weather parameters, and then the activity, clothing, age, gender as in other parameters for calculation of PET. The details of PET values the details of Raman model can be found here. A methodology also, the basic methodology or the schematic diagram has been shown here, where you can see that we first calculated the observed PET using the observed data, so that we can measure the prevailing thermal stress over the country during heat wave episodes, and then we simulate the PET for the same heat wave events using WRF simulated values to determine the skill of forecasting. Now, the heat wave events chosen for this study are from March 21 to 28, April 24 to May 1, and May 18 to 25. And for all of these events, the heat wave WRF model is simulated 9 days earlier. Here is the WRF model setup, for which we have used a very finer resolution of 10 kilometers using PBL physics, UNCL University schemes, and for long wave radiation using rapid radiative transfer model, and 2-year scheme for short wave radiation, and the whole setup has been shown here. Now here is the simulated result for the April heat wave event. From where you can see that there is an extreme temperature line, that is the 42 degree Celsius temperature, have been simulated by WRF model since 9 days prior, so which can be a clear indication that WRF model can simulate heat waves quite well with the lead time D9. And for also we can see that the most temperate zones actually lie across the western part, where actually the Rajshahi, Khulna, and then the central portion Dhaka are the most heat affected regions of Bangladesh. And also here is the May simulated events for showing using grads. And from these two pictures, and we can conclude that the heat wave in Bangladesh is actually the result of advection of our maximum temperature from the West Bengal. The most temperate zones actually first formed on the West Bengal and then advected towards Bangladesh across the western boundaries. Now, for both April and May events, we have here we have shown the simulated relative humidity at 0900 UTC for 6 days, and it is found that the relative humidity was quite low at that moment for both of the heat wave events, and lying around 40 to 60%. Looking at the surface sea level pressure, we also found that the trough of low pressure has been found to lie over West Bengal and the adjoining regions for most of the time at 0900 UTC for all these two heat wave events, and a trough of high pressure is found over the eastern part of Bangladesh. Now coming to the observed PET scenario. Now here these pictures have been shown for the May heat wave event, and the values are shown here for greater than 30 degrees Celsius, as 30 degrees Celsius of PET value indicates the moderate heat stress. So you can see at a glance that in most of the days, the heat wave with the heat stress were actually greater than 30 degrees Celsius, which implies the moderate heat stress prevailing over the 8 stations of our study. To get the more detailed view, we have shown the block box plot here, where you see that for the March heat wave events, that observed weight or the stress value is actually not a very alarming, just lying below 31 to 30. Even if it's 35, so there actually lies 25% of values. So we are excluding, but for April and May, the level of thermophysiological stress is quite higher. In fact, for Borishal here, around 50% of values lies between 31 to 37.15, which expresses the moderate to strong heat stress over this heatwave event. And for May heatwave event, around 50% value lies over strong heat stress and reaching the extreme heat stress values. This case also follows for other divisions, as you can see from here, like from Chattogram, Dhaka, Khulna, and also for Mymensingh, Rajshahi, Rangpur, and Sylhet. For all the 8 events, the heat stress, or the most of the heat stress actually prevails during the month of May, probably due to the presence of temperature as well as relative humidity and other factors. Now, it's also an fact that the maximum temperature, maximum PET value reaching 44, 43, and this type of level, and in fact, this type of level indicates the alarming rate of extreme heat stress, which is directly linked to heat-related morbidity. Now, comparing to the comparative study of observed weight and simulated weight that is used by that it has been simulated 9 days prior, you can see at a glance that the simulated weight is quite lower for all of the stations than the observed weight. So even if it's alarming, but the simulated weight is lower. So to find out the reason, we compare all the weather parameters used for calculating weight. Here for brevity, I have shown only 3 stations. Now please look at this Borishal and Rajshahi. So here you can see that the observed temperature, which has been shown by yellow, and simulated temperature by purple, this WRF has quite nicely captured the pattern of observed temperature here in Bangladesh, but the WRF, the simulated wind speed, is quite higher than the observed wind speed. And this case is found for most of the stations. So as the wind speed is greater, it can be said this gives quite a strong ground for this lower simulated value. Now, simulated value is lower because the simulated wind speed is greater than the observed value. Now, coming to the forecasting skills, we have used Wilmot's Index of Agreement for using as a performance metrics for the WRF, for the simulation of WRF model of the PET to the observed value. Now we have used D because it's a dimensionless bounded parameter for and the value of D is equal to 1 emphasize perfect model, where D equal to 0 is a complete disagreement. Now from the value you can see the blacks are of high agreement, while the yellow here shows moderate and blue is quite lower. So from these results we can conclude that now, moderate to strong heat stress is sensed during heat wave across Bangladesh. The resulting focus for PET are characterized by high skill for events in March and April over the region, except for Chattogram, as you will see here. For this value are quite lower, but the low values of performance matrix D over Chattogram may be accounted to the model's difficulty in simulation over the hill tracts and complex geography of that region. And we obviously need more studies for the betterment of our performance metrics or the simulation. And during May, probably going to the erratic behavior of wind speed, relative humidity, the skill of forecasting is moderate, but still it is a very good measure or the stepping stone in the analysis of or in the development of heat health warning system. Thank you very much. Here I conclude my presentation, and if anyone have any question, please ask.
Thank you very much. It is very important for the care the heat health.
Yes.
Any question?
I am
Comment?
raising hand.
Yes, Iskawa-san, please.
Okay. Thank you very much. It's a good presentation. I have been deeply impressed in But I have two concerns.
Sure,
First,
please.
yeah, you use a resolution of 10 kilometers, right?
Yes,
Then you use a cumulus parameterization.
yes, crane
Okay.
fished.
Yeah, I have anxious about that because the surface temperature is affected by the solar radiation deeply.
Mm.
Okay, so what the cloudiness is appeared in your model. Okay, so that is a concern. The cloudiness is not directly maybe considered in cumulus parameterizations. And so it may depend on the resolution of the horizontal resolutions. So I suggest you to check the horizontal effect of horizontal resolution of the model. Okay. And the
But it is
second thing, and the second comment is the humidity. Okay, as surface temperature is very much affected by the soil moisture, you know. So you have to check where the soil moisture is appropriately
well, yes, I got your point of view. Thank you very much for your suggestion. Now, soil moisture is obviously an important factor for analyzing heat waves, but as my study is concerned directly to human health, for that reason, I am not. I haven't using soil moisture in this particular study, but yes, I obviously keep this in my mind, and for further studies, we'll use your suggestion. Thank you very much, sir.
Yeah, thanks.
Any other questions, comments? It's okay. Thank you very much.
Yes, thank you very much.
Okay, thank you. Ishikawa-san is okay. So next presentation is by Reba Farzana-san.
Yes.
Are you ready?
Yeah, I'm ready.
Okay, please start the presentation.
Is it visible?
Yes.
Yes.
Good afternoon, everyone. At first, thank you for giving me this opportunity to present my research here. I'm Reba Farzana, and I've recently graduated from Department of Disaster Science and Management, University of Dhaka, and currently working as an intern at Bangladesh Meteorological Department. Today, I'm going to my master's thesis, which is titled as Assessment of Urban Heat Island and its Impact on Temperature, Precipitation, and Evapotranspiration. Climate change is poised to affect all of our lives. What do you think of when you talk about climate change? Maybe polar bears or maybe the melting glaciers in Arctic? Well, today I want to say that when you think about climate change, you should also think about cities, especially the cities in the developing countries, because it is the places where more than 50% of the world's population now calls home, especially the cities of the developing countries. Because we all know that although the cities of the developed world are the major contributor to global carbon dioxide emissions, the cities of the developing countries are likely to face the deadliest effects of climate change. And when we talk about climate change and cities, all of this stuff, the major issue that comes into light is the urban heat island phenomena, in which cities are warmer than the surrounding areas. The urban heat islands occur when cities replace the natural land covers with dense concentrations of pavements, buildings, and other surfaces that absorb and retain heat. And these intensified built-up areas consequently affect the temperature. This problem, this established urban heat island, which is Dhaka city, the capital city of Bangladesh, and another is Mymensingh area, which has recently become a city corporation and hence going through rapid development recently. So the general objective of this study is to assess the long-term impact of urban heat island on temperature, precipitation, and evapotranspiration compared to an urban area that is under rapid development recently. The specific objectives of this study includes to assess the land surface temperature using available Landsat images, to analyze the long-term annual and seasonal trend of air temperature and precipitation using observational and graded data, to investigate the long-term annual and seasonal evapotranspiration by using the empirical APTO model for post-monsoon and winter of 2020, as well as summer of 2021, using the newly launched SNAP sanity application by European Space Agency. The research question that was answered throughout this research is, what is the temporal impact of urban heat island on the temperature, precipitation, and evapotranspiration compared with an urban area that is under rapid development recently? So let's move on to the methodological framework of the study. At first, the urban heat island was assessed using the Landsat images from 1990 to 2019 for the month of November, December, January, and February. Since a large amount of images were assessed, land surface temperature were calculated using the Google Earth Engine platform. The post-processing were performed in Python and ArcGIS. Then the annual and seasonal temperature and precipitation were analyzed using station data and graded data also. The temperature and precipitation data for Mymensingh and Dhaka station were collected from Bangladesh Meteorological Department for the years 1990 to 2020. And as for the graded data, the Climate Hazard Center infrared temperature with station, which is charts in short and charts in short for precipitation. These data were used for the graded data for temperature and precipitation. And the data were mainly divided into 4 seasons, which are pre-monsoon, including the March, April, May month, the monsoon season, which includes the June, July, August month, and the post-monsoon season, which includes September, October, and November month, and finally the winter season, which includes the December, January, and February months. The trend analysis for annual and seasonal temperature and precipitation were performed using Excel and Python, and the Manscandel and SenseLog estimator were conducted using RStudio. Finally, the evapotranspiration was calculated in 2 ways. At first, the empirical APTO model was used to calculate the evapotranspiration from 1990 to 2020 using the solar radiation data. That model was used because it was suggested as the best alternative to the FAO Penman-Monteith model by literature for Bangladesh. It's great accuracy and credibility in highlighting the significant spatiotemporal fluctuations of evapotranspiration has made it into a great option actually. And the annual and seasonal average were calculated and assessed using Python and Excel. And finally, the Manscandel and SenseLog estimator were performed using the RStudio software. And the second method for evapotranspiration estimation involves actually the application of the newly launched Python configured SNAP sanity plugin, which was developed by the European Space Agency. The evapotranspiration was calculated for post-monsoon and winter of 2020 and summer of 2021. And the recently launched Sentinel-2 and Sentinel-3 images actually created the new opportunities for precise and operational modeling of actual evapotranspiration. Because while the Sentinel-2 images have the capability to estimate the scale of vegetation, the Sentinel-3 images, on the other hand, can acquire the thermal observations. So by combining these 2 information, the sanity application calculates the evapotranspiration. And it is a completely new application, as I have said before, for the large scale, high resolution evapotranspiration estimation. So it was very hard to do in the before. And this is why this study applied this method to quantify the large-scale evapotranspiration and to see the applicability of this plugin in Bangladesh. So here is the framework for the evapotranspiration calculation using the sanity application. So as you all can see, at first the Sentinel-2 images were pre-processed in SNAP, which finally gave us the aerodynamic parameters. Then the Sentinel-3 images were also processed to get the sharpened LST product. And through SNAP, the ERA5 reanalysis data were downloaded and it was prepared and interpolated to the Sentinel-3 overpass time, which finally gave us the meteorological data required. And finally, combining the biophysical parameters, structural parameters, and the sharpened LST product and also the aerodynamic parameters, we calculated the long wave irradiance and net short wave radiation. Finally, combining this information with the meteorological information, we got the daily evapotranspiration. Now let's look at the results now. So for the land surface temperature, the mean land surface temperature of Dhaka and Mymensingh were close to each other in the 1990s, as you can see. But however, the difference between the two areas increased rapidly around 2005. The mean LST in January for Dhaka dramatically jumped throughout the last 30 years, actually increasing from around 18.8 degrees Celsius to 23.1 degrees Celsius, a change of nearly 4.3 degrees Celsius. And the LST increase was highest for January for Dhaka. And the highest increase, on the other hand, for Mymensingh occurred in February, while experiencing an increase of about 3.4 degrees Celsius. And here is the LST maps of Dhaka and Mymensingh for 1990, 2000, 2010 for January. And you can see that the LST has increased gradually over the years for both areas. However, the LST for Mymensingh remained lower than Dhaka actually. Now, let's see the results for the annual temperature using the BMD data. Annual temperature is about 0.9 degrees Celsius for Dhaka city and 0.6 degrees Celsius for Mymensingh city. And these are the seasonal graphs for the temperature increase over the last 30 years. The temperature increase was highest in pre-monsoon for Dhaka city, in which the temperature raised from 27 degrees Celsius to 28 degrees Celsius roughly. And the highest increase for Mymensingh was also in pre-monsoon, increasing about 26.5 degrees Celsius to 27.5 degrees Celsius. And this is the analysis for charts data. The yearly analysis of charts data revealed that the temperature increased about 0.8 degrees Celsius for Dhaka and 0.4 degrees Celsius for Mymensingh. And the highest increase of temperature for both areas occurred in monsoon season, changing about 0.9 degrees Celsius. Although the highest increase was the same for both areas, the trend has been substantially lower in Mymensingh than Dhaka actually during the other seasons. And here is the analysis for precipitation using the BMD data, which is station data. The trend analysis of station data for precipitation actually revealed that the annual total precipitation decreased the most for both areas, and both areas actually shows decreasing trends in all seasons except in the monsoon season. And this is the analysis for precipitation using the CHIRPS data. According to the CHIRPS data analysis, the annual total precipitation trend remained almost similar for Dhaka, whereas the trend for the post-monsoon precipitation other seasons also shows up the monsoon season, and for Mymensingh and winter season precipitation shows while showing an increasing trend in monsoon season. And the evapotranspiration analysis transpiration calculation and lower in wind. These are can you hear me?
Yes.
I'm continuing now. So these are the evapotranspiration maps for Dhaka and Mymensingh. It shows that the evapotranspiration in the urbanized areas actually, and the mean elevation for Dhaka increased very rapidly after the year 2000 compared to Mymensingh. And air temperature trend of Dhaka has been substantially higher than Mymensingh, although the highest temperature increase were almost similar. The precipitation trend for Dhaka has been significantly lower than Mymensingh, and the seasonal evapotranspiration trend for Dhaka continued to be lower than Mymensingh, while the yearly trend remained nearly identical. And according to the sanity, evapotranspiration was much lower in Dhaka than Mymensingh during post-monsoon and summer season. So that's all. Thank you so much. If you have any questions, please.
Thank you very much. Very interesting presentation. Any question and comments?
I think we have no question.
Yes,
Please.
please. Yeah. Any question? Okay. I have one question. So on the you compare the two cities of Dhaka and Mymensingh. So Mymensingh is a suburban city, and Dhaka is a capital. So and some difference. This is a very different situation. Do you have any plan to the same analysis to the other cities and do the very rural area?
Yes, so we have the plan to continue further this study for the rural areas. Actually, one limitation for conducting this, for comparing urban heat island with an urban rural area is that the data limitation actually for our rural areas, because it's very hard to collect data for completely rural areas in case of the station data, because the BMD stations are located in that areas which are comparatively like easily accessible, and there are some urbanized positions thing to do, but we are trying because some new stations are established recently. So if we can get access to that actually. Thank you.
Thank you very much. Any comment or question?
Yeah, I have a comment. Dr. Hayashi, how are
Yes.
you?
How are you?
Yeah, fine, fine.
Yeah.
So regarding your question, I think you are very much familiar with the meteorological observatories of Bangladesh Meteorological Department. Problem is once we start the any station, it has been located over the urban area or rural area. But after few years, its environment are becoming changing. So while we are starting with this, that means article or with this research, it was very much difficult to get the real features of the rural area. So you might be knowing that Mymensingh station has been located in the premises of Mymensingh University area, and surrounding of that station, as of my understanding, till now there are no, or I would say that very limited urbanization activities. That's why we have chosen this one. So in the next presentation, you will have seen one more study similarly has been conducted by one of our students. He has been studied on the similar study for the case of Chittagong as well as Sitakunda region. So as of my analysis or as of my understanding, at other places, maybe the environmental condition has been changed during the last 2 to 3 decades, where we have started the observatory at the remote location area. So it has been dynamically changed due to our urbanization condition or development activities. Once any new station will be there in future, very remote area, but problem is there will be limited data accessibility or limited data records of that area. So I think as of my understanding, you have many stations installed over the northeastern parts of Bangladesh. If you are having any continued observation from any area of northeastern part, I think you can share that data with us so that we can have a comparison between the urban station as well as the rural stations. Thank you.
Thank you very much. So unfortunately, we cannot visit Bangladesh in this about 2 years. So if possible, I will visit Bangladesh and restart again the observation. Thank you very much.
Okay, thank you.
Thank you.
So thank you very much, Reva-san. So on the next presentation is Dr. M. Ashwaku Ramanson. Please start.
Yeah, can you hear me?
Yes.
Yes.
And I can watch your presentation file. Please start. Okay.
Okay. Can I start now? Okay.
Yeah.
Thank you very much. Thank you to everyone who is attending, and also to the organizer of the International Conference on Meteorology and Climate Science 2021, Department of Meteorology, University of Dhaka. So it's a very nice time to present again, because last time I also presented. So thank you everyone to give me the opportunity to present again here. So my presentation is on summer monsoon rainfall prediction of Bangladesh, and I want to use the machine learning techniques, and also I want to have explorations on some regional climate model simulations and observations as well. So outline of my presentation is today. Number one is the objective, then I'll describe the data and methodology. and then I will show some results, and then finally I will draw conclusions. So objective and motivation, we can say, to find the recent trends, variabilities, and predictability of monsoon rainfall over Bangladesh, and then to find the remote ocean influences to the monsoon rainfall over Bangladesh. And the third one is the use of machine learning techniques for monsoon rainfall prediction. And then finally, simulation of monsoon rainfall using high resolution climate model, the REXIEM. So here the idea was to see that the recent time, we can see also in the next slides that the recent time we see some too much variability of the rainfall, especially the monsoon rainfall. Very recently, it's a matter of big question that what we can see, the South Asian monsoon have something special characteristics, but for our country it has something different. It's like it's not necessarily that the monsoon over a large part of the India will be similar to our country. So this is the problem. So we can see why, means like we can see the relationship, the large scale relationship also with the SST relationship. Is there any influence from the SST or something like that? It was the motivation of this research. So now the data and methodology. For the data, I have used the next generation ERA 5, that is ECM WF reanalysis version 5 data, which is available now from 1979 to 2020. Even they have prepared the experimental 1950 to 1978. So there is opportunity also to check that data as well. But this data is actually, we can say, is more reliable because I mean that from 1979 to 2020, because there are lots of opportunity to have the assimilation and other techniques to improve the data. And also the ground station is much more, there are satellite stations and many other things are now available to have better quality data. Anyway, it's a good time to see how it behaves without. Then I also use that climatic research unit data for precipitation, and I use that SST from the ERSST. I have also used the Bangladesh Meteorological Department BMD observed station data. And then the methodology, I use the regression trend and also the machine learning techniques for multiple nonlinear regression. We all know that the relationship we use that is linear, and there is a question, is it linear or not? I want to say that the natural variables have always some non-linearity. So how to keep them as they are? Means I want to say, if we have the trend line, it will be linear trend line. We guess that it is increasing or decreasing. But if we check with the non-linearity, maybe it will be not like that one. So all the variables are non-linear according to the time series, but we are imposing this linear assumption to have our analysis. This is the limitation of the conventional analysis. So machine learning can help us. Why? Because it is used the non-linear concept. It is also regression, but it is multiple regression with non-linear concept. Means like I want to say that we feed that regression with according to some degree, not that I will get that relationship to in the concept of linearity. This is the advantage. And then I use that REXIEM model, that is the ICTP REXIEM model. It is very high resolution, 12-kilometer simulation. So as it will take a longer time, so I just want to explore the 5-year simulation, and then we can further extend this experiment. So now the results. This is the mean rainfall. I mean JJS rainfall from the ERA 5 and CRU over Bangladesh from 1979 to 2020. So we can see the rainfall over the northeastern part of Bangladesh is higher always. It's in the JJS and also for the crew. And also we can see there is increasing of the northeast, I say the southeastern region of Bangladesh, this one. And also something here. So later on I checked for the trend. We can see also just after 2 slides, I want to show the standard deviation as well. But the standard deviation also we see some variation is there in the southeastern part. And it's obvious that the northeastern part will be also variability will be there. So now this is the linear trend analysis. So we can see very strong decreasing trend over the northeastern part of Bangladesh, also whole the north region. So, but the ERA 5 is not showing that negative here. That I want to say the northern part of Bangladesh, northwestern part of Bangladesh, it is positive. But for crew data, which is very close to our station data, it is showing that all through the north region is negative trend. So now I took this Rangpur station of the almost northern part of Bangladesh, and then the Sylhet station and also the Teknaf station to see the anomalies. So these are the anomalies of the Sylhet June rainfall and also the Rangpur. We can see this is decreasing trend. So it is also, especially for the Rangpur one, it is significantly decreasing this slope. So, but for the Teknaf station, it is increasing. So this is the observed. So we cannot argue with that one. It is reality because this is the station data. So this following this, I want to check the non-linear relationship with this one with these 3 station data with the global SST. But for the global SST, I took the spring one because it is the 1 season lag will show because the ocean condition somehow will determine the next season's rainfall. So now it is first one is the Rangpur one. This is station data correlated over the global SST. We can see in the equatorial Pacific region there are some positive correlation and also negative as well. This is dipole we can say here. Also similar for the station, but the main region of the monsoon, sorry, equatorial Pacific is positively for both. I want to say that Nino 3.4 region is positively correlated with the both Sylhet region and Sylhet region rainfall, and also the JJS Rangpur region station data. So now I want to say that can we predict this the spring SST with that next season, that is the summer rainfall? And might be there are other predictor as well, but it is very strong predictor for any other part of the world. We say that ENSO effect. And then we can see for the Teknaf station data, it is negatively, I think almost opposite sign is coming here. So we can see very small country Bangladesh have variation with the rainfall with the global SST. I want to say the 1 season lag SST. So this can give us hints to use this relationship, but again we have this linear regression. We cannot 100% rely on this one. So now I use that machine learning technique for the non-linearity using the Nino 3.4 March to May, that is spring index. And also the other predictors are that the heat low over the Indian region, the simultaneous one, and surface temperature of the same region, means that I want to say that this is the local one, and also ERA 5 rainfall. So using this 4 predictor this blue color line is showing the predicted one, but it is not matching well, but at least something is coming with this one. So we can say there is possibility to use further more relevant other local variables like that. We can see the humidity and other things, so that we can make more better prediction for the test and the training period. So it will improve us that one. So this is the one of the sample one, and then now I use the idea to how to simulate for Bangladesh, the Rexium one. So this is the 2006 to 2010 simulation results. This rightmost one. This is the Rexium result, and we have seen before the true and error data. So there are some discrepancies. I think the southern part for the model, it is showing very low rainfall, but the Technaf is higher. So to my understanding, maybe we have to look further for the parameterization and the convection scheme. So there is a good chance to use again and again, and we can optimize our model to simulate the better rainfall over Bangladesh. So that it will be helpful for us. But still we have the questions, how can we predict our rainfall with perfect one? Means like this is dynamically downscale. Our all 5 forcing data for this Rexium is from NNRP2, that is the NSAP NOAA data. So we can use whole simulation, and before that, means like I want to say the whole period from 1979 to 2020, but before that we can use this idea how to can improve more and come close to the observation. So these are all the things I have presented today, and I want to conclude with this these things, that the recent trend of monsoon rainfall in northern regions and also northeastern regions is decreasing. And also the recent trend of monsoon rainfall in southeastern regions of Bangladesh is increasing. And predictability of monsoon rainfall in Bangladesh using SST is helpful from the station specific data. Just like I want to say for a specific station, it is showing some specific result. And also it is the lag relationship. And then the machine learning technique can be helpful to predict the rainfall, because we have that only the limited one within the time frame, but we can use it easily after the testing has successful. We can use it further for the future prediction. And finally, the Rexium climate can be helpful to assess the climate of Bangladesh, because it is not time bounded. If we can give the model the correct one, it can be give us even the scenarios, and as well as the strong hints how we can predict our future rainfall. It will be helpful tool for us. Thank you very much. Thank you, everyone. Now, any question we can.
Thank you very much. So, any questions and the comments to the presentation?
Sorry, can I?
Yes, yes.
Yeah. I think that it is new approach machine learning for multiple nonlinear irrigation. You showed that here only the Technaf and Rangpur. Have you any plan to the other station for study in the study?
Yes, I can use the other station data, and it will be very interesting, because means like it can give us something for the machine learning technique useful for our rainfall prediction. But the only thing is we have some limited data, like that, for example, almost all the data are available, I think 1980 onwards. So also the recent year data. So once I have all the data, I think I can, yeah, I have planned to use all of them, and I can complete all the stations once it is there. Okay. Yeah.
Okay, thank you. Thank you very much.
Any questions?
Can I have a question?
Yes, please.
Yes, yes.
Yeah, thank you, Dr. Ashfaq, for your nice presentation. And you have been trying to predict the rainfall over Teknaf as well as some other stations. And you have been using so far, I have seen it is maybe I haven't complete one. Maybe you have been tried with the sea surface temperature has been taken as a predictor. Is it okay?
Yes, yes, yes. Nino 3.4 index.
Yeah.
Yes.
Yeah. Can you please try with this prediction facility with the Indian Ocean dipole mode? That means there are one SST. That means reflection is there. In addition, you can
Yes, yes.
take
Yeah.
the
We can
western part of the
IoT data as
Pacific
well.
region
Yeah,
that is very much influential to Genesis as well as some other related aspect like MZO, Madden-Julian oscillation.
Yeah,
Can you
yes,
please
yes.
try with that one? That is my submission.
Yeah. I can try. Index can be available.
Yeah.
And the idea is to use all the indexes like MJO or maybe IOD. It can be relevant to us because, and also I have planned to use for the IOD as well. But one important thing is here, the simultaneous relationship may be better, but it is not helpful because we know that SST is slow moving. So it has memory to carry on.
No,
like
I am not
6 months
talking
or so.
about talking about the, that means, I want to say that you can try it with different indices in different mode, individually, not conjugate analysis. Then you can be able to see how IUD is behaving with rainfall over Teknaf region, how SST over Western Pacific has been alone take that means have the predictability over Teknaf region or any other parameters individually.
Yes, I got
because
the point.
these are the resultant information from the sea surface temperature only.
Yeah, I got your point that this resultant for indexes like indices like IOD and so on, maybe other things like the MJO. The point is like that. If I have the single one-to-one relation, for example, IOD and the Rangpur station data, maybe it will give something very strong. But for the same data, maybe not good. That's why I use the machine learning technique, that is the multiple regression. So it will remove the other influences and give only that one. So finally, the resultant will be good. Yeah, I agree with you. Yeah, I will do it. Yeah. Okay, thank you.
Thank you very much. Any other questions, comments? Okay, thank you very much. The presentation.
Welcome.
This is the final presentation is by the Abeda Tabassum-san.
Yes, hello.
Hello, you are available?
Yes, Abeda Tabassum, yes, I'm available.
Okay, please start the presentation.
Yeah. Just a second. Can you hear me?
Yes.
Okay. So hello everyone, this is Abeda Tabassum and I have recently completed my post-graduation from Department of Disaster Science and Management, University of Dhaka. And today I'm here to present my research on assessment of urban heat island and its long-term impact on temperature, precipitation, and evapotranspiration, a comparison between Chattogram and Kumilla. First of all, I would like to thank Professor Daman Mahmoud Enamul Haq and Dr. Mohammad Abdul Manan sir for providing me with proper guidance and all the necessary data, without which completing this research would have been really impossible. And I would also like to thank the organizers for ICMCS 2021 for selecting my work and allowing me to present here. Okay, so let's first discuss about urban heat islands. When we build an urban area, we replace the vegetation and also the soil surface with impervious surface like paving materials and building materials.
By doing this, we are basically warming the urban areas, and this generates a temperature difference. This is what we call the urban heat island. So to summarize, urban heat island is a metropolitan area, or often called a downtown, which is higher in temperature than the surrounding urban residential, suburban residential, or rural areas. Urban heat island is a very important concept because of the fact that this is where most of the people live, and in the next 50 years, we are going to see about 80% of the global population living in cities. So the objective of this research is to figure out the long-term impact of UHI, which is 30 years from 1990 to 2020, on temperature, precipitation, and evapotranspiration compared with that of an urban area undergoing rapid development. To achieve this objective, I tried to assess the land surface temperature of the study areas using the available Landsat images. Secondly, analyze the annual and seasonal trends of long-term mean air temperature and total precipitation of the study areas using observational and satellite data. Then I tried to investigate the long-term annual and seasonal mean evapotranspiration from solar radiation data using the empirical Aptiv model. And finally, estimated the evapotranspiration of the study areas for post-monsoon and winter seasons of 2020 by processing the Sentinel-2 and Sentinel-3 satellite images using the latest ESA SNAP SEN-ET plugin. So the question of this research is, what is the temporal impact of UHI on temperature, precipitation, and evapotranspiration compared with an urban area which is undergoing rapid development? And to do this, the study areas are Chattogram and Kumilla, denoted as A and B respectively. As Chattogram is a well-established UHI, while Kumilla is still transitioning to urban, these two cities are chosen to conduct the research. Moreover, among the 34 stations of Bangladesh Meteorological Department, Chattogram and Kumilla stations are two of the few with long-term data available. So here we can see the overall methodological framework of the study. To calculate the LST, a total of 300 Landsat 4, 5, 6, and 7 images with less than 5% cloud coverage were processed in Google Earth Engine according to availability. As for temperature and precipitation, the mean temperature and total precipitation were processed to find out the seasonal and annual variability of the areas using non-parametric main candle test and sense slope estimator. Two different types of data were analyzed. The PMD observational data collected from the Bangladesh Meteorological Department, and the satellite data which were collected from the website of Climate Hazard Center of UC Santa Barbara Geological Department, which are denoted as CHIRPS for precipitation and CHIRPS for temperature. Next, evapotranspiration was calculated using two different methods. The first one is Aptiv empirical model, which uses solar radiation data to compute evapotranspiration. This model was used because, according to the literature reviews, Aptiv model is the best suited ET calculation method for Bangladesh because of its simplicity and higher correlation with the standard Penman-Montet method. The second evapotranspiration method is the data sharpening LST and land surface fluxes modeling scheme, shortly known as SEN-ET, was conducted using Sentinel-2 and Sentinel-3 image with ERF5 meteorological data for post-monsoon and winter seasons of 2020. This method uses Python configured SNAP, and this is the detailed framework for SEN-ET. As you can see, at first, the Sentinel-2 optical data was used to calculate the aerodynamic parameters. The pre-processing of Sentinel-2 creates these as resultant products which are used to then compute the aerodynamic parameters. Secondly, Sentinel-3 thermal data use Sentinel-2 image to create a higher resolution LST or the sharpened LST. After that, the ERF5 meteorological data was downloaded from the website and was converted to use in SNAP software using the elevation file. After that, the outputs were used to calculate the irradiance and shortwave irradiation, and then the land surface energy flux. Finally, the land surface energy flux and the meteorological data is used to estimate evapotranspiration. So let's move on to the results and interpretation part now. As for the mean LST, we can see that even though over the years, land surface temperature for both Chattogram and Kumilla shows increasing trend, the trends for Chattogram almost always remained about 1 to 2 degrees higher than that of Kumilla. Here we can see the mean LSTs for January, February, November, and December. Due to the image limitations, we couldn't collect the images during the summer time. Here we can see the decadal LST maps, which show that the LST over the 4 decades continuously increased for both cities. However, the temperature for Kumilla remained below Chattogram. So these are the trends for mean temperature obtained from BMD data. All seasons showed increasing trend. However, there remained a difference between two cities. Chattogram had visibly higher temperature over all seasons, except for in monsoon. As seen in the graph, Kumilla temperature rose above Chattogram during the 2000s and remained above until recently. These are the CHITS data. We can see similar yet slightly different changes. Graphs show that Chattogram in the 90s was a lot warmer than Kumilla, especially in post-monsoon and winter seasons. But over the years, Kumilla began experiencing almost the same temperature as Chattogram, and the annual trends show a steeper slope for Kumilla rather than Chattogram city. The mean precipitation trend calculated from the meteorological data show irregular trends. Chattogram city experiences higher precipitation in monsoon and post-monsoon, whereas trends for Kumilla remain unchanged except for winter. During the rest of the seasons, both cities experience similar precipitation with very insignificant differences. As for the CHIPS data, Chattogram experiences higher rainfall than Kumilla over the years, especially in monsoon season. But in pre-monsoon, Kumilla has higher rainfall. During the other two seasons, both cities experience similar precipitation with very insignificant differences. Here's the evapotranspiration data, which are estimated using the solar radiation. These show irregular trends as well. Trends for Chattogram remain almost unchanged except for pre-monsoon, where we can see a slightly increasing trend. For Kumilla, pre-monsoon and monsoon evapotranspiration show decreasing trend, while the rest of the seasons remained unchanged. So this is the graphs for evapotranspiration calculated using the Sentinel images. The mean evapotranspiration over post-monsoon and winter season of 2020 show that mean decreased in winter for both cities. And these are the resultant maps for evapotranspiration estimation. The greener areas here show high evapotranspiration and the blue areas show zero evapotranspiration. We can see that the maximum evapotranspiration decreased from post-monsoon to winter. So to summarize, we can say that the impact of UHI is clearly seen in the temperature trends. The temperature trend for Chattogram, whether increasing or decreasing, always remained about 1 to 2 degrees higher than Kumilla. The annual monsoon and post-monsoon precipitation trends of Chattogram was always higher than Kumilla, but the pre-monsoon and winter precipitation trends were almost similar. As for evapotranspiration, we can say that between post-monsoon and winter, it occurs most during post-monsoon season for both the study areas. The daily evapotranspiration remained between 5 to 5.5 millimeter per day in post-monsoon and about 3 to 4.5 millimeter per day in winter. So overall, it can be concluded that the UHI has pretty high impact on temperature and precipitation, but almost less to no impact on evapotranspiration. So that is all from my presentation. Thank you for your attention. So if you have any questions, please ask.
Thank you very much. The very good, very interesting presentation. Any questions and comments?
Hello.
Yes.
Dr. Chair, Honorable Chair, can I have a comment on that one?
Okay, please.
Yeah, though I am the co-author of this research, but even though I have something in my mind, I think some geographic correction can be taken into consideration, because Chittagong and Kumilla, both these stations are located at different latitude, and environmental other factors, like one is located in the coastal areas of Bangladesh, which have good influence of ocean influence is there. But in the Kumilla station, as it is located in a very flat land, as of my understanding, it has no direct ocean influence. So I think some geographic correction can be required for getting the improved result. And so I will suggest Abeda to take into consideration before publishing this paper. Thank you.
Yes, sir. Okay.
Any comments or questions? I have one question.
Yes, sir.
Why the Chittagong and Kumilla is selected to this research?
Well, Chittagong is well-known UHI, and
Yes.
as for the rural area, because we don't have any stations in like totally rural areas in Bangladesh, and this study requires 30 years long data. So among the stations that are both in rather rural or not like totally urban area and has 30 years of data, I chose Kumilla for the urban area.
Okay, thank you very much.
Second area.
So, but Bangladesh has so many other cities. For example, I visited many times in Bangladesh. I know well about the situation. So, but the condition, meteorological condition is different in the western area, in the coastal area, and the northeastern area, and northwestern areas. Do you have a plan to this analysis to these to apply the other places?
Yes, I do. As you have seen in other presentation by Reba Farzana, she worked on Dhaka and Mymensingh, and I worked on Chittagong and Kumilla. So we are planning to work combine these four cities and also add other cities so that it covers almost the whole area of Bangladesh. And in that way, we can totally understand the overall situation here.
Professor Ishikawa, please.
Yes, I have one paper regarding to the urban heat island near coast. So in the coastal areas, the land sea breeze decrease the effect of the heat island during the daytimes. So in that sense, I think it is a little bit careful. You have to be careful to understand the Chittagong's result. Maybe it is a coastal harbor cities. The inland cities, that is not the, you need not worry about the land sea breeze effect. Okay, in that sense, I think it's interesting to compare the Dhaka and Chittagong in the aspect of the effect of land sea breeze. That is my comment.
Okay.
Yes, I'll keep that in mind. Thank you.
Sir, I have an observation.
Okay.
Actually, we know that the heat area, I think that at first Dhaka, then we can consider the Rajshahi, because it is a very warm area. Rajshahi, another Jashore Kushtia. I think that in this study, if we consider Rajshahi and Jashore Kustia, we can get maybe better result.
Yes, Mr. Boslo, your comment is very valid. It can be done. But one thing you have we have to remember that the climate features of Dhaka as well as climate features of Jashore Kustia are not similar. So that has to be one of the points to take into consideration of the stations. One would be in rural area, one, and again another one would be the that means urban area. In that way, I think in that case we have to consider Rajshahi station with Chuadanga station. That might be the little lower local area, and Rajshahi maybe in the city area. This way we can do that one. But one mandatory part is there. Every station, that means the comparable stations, has to be located in a similar climate pattern area. Thank you.
Any questions and comments? It's okay. Thank you very much. The presentation.
Yes.
Abeda-san. Okay, thank you.
Yes, thank you so much.
All the presentation is finished. We have to we have a time to all the present and time to the questions of all the presentations of this session. Any other questions to all the presentations? Okay. So we have to conclude this session. Fortunately, we have time. So in this session, the first two presentation is Tibetan Plateau and connecting the heat, the observation and the Tibetan Plateau and its effect to the Bangladesh meteorological environments. The another presentation is on the forecasting of data for the few humanitarian actions, and the other two is the other one is heat warning, heat wave, and heat and rating to the heat wave conditions. The other one is in this section, the heat island or heat wave, and heat is one key word of this session. I think this heat is a very important keyword to the Bangladesh meteorological data. So I think the BMD's responsibility, the observation responsibility, is very important in future, and the research together with the other organizations. So, for example, in the heat health, early warning is very connecting to the medical organizations. So, and do you have any relationship between the other organizations in the early warning system or and observation systems? Do you have any answers to my question?
Well,
Sorry, sir. Actually, the BMD is the only early warning system provided at present Bangladesh.
Okay.
Sometimes the BMD provides the early warning, and then coastal area people, especially CPP, other organizations that they deliver the early warning forecast.
Thank you very much. So I think the meteorological aspects is very important and responsible for the early warning. So and the relationship between the other organizations, because as well as the weather forecasting. So I think the climatological condition is very different from the is changing now. So and it is very important, and research and observation is very important in Bangladesh also. So and I'm thinking that the research, organized research in Bangladesh is very important. The BMD and the university and the research organization and the government. So the management, all the organizations need to manage this situation. So this is my concludings. And personally, and I fortunately joined this international conference on meteorology and climatic scientists 2021. So I'm the very interesting and very significant presentation is very impressive for me. So and unfortunately, it is very difficult for me to visit Bangladesh and India and the South Asian countries. So if the situation is improved, I'd like to visit again, and we have to discuss with again and directly. This is my complete. This is my concludings. Thank you very much.
Hello.
Hello.
Yeah, Professor Hayashi, how are you?
Very well, thank you. And you?
Yeah, I'm fantastic, fine. Thank you for your valuable time. I know that you were very busy, and we are very happy to have you with our conference. Thank you for giving us your valuable time. Thank you.
Yeah, no.
I'll see you sometime in Bangladesh soon, okay?
Yeah, I'm planning. I have a plan to visit again. So in the next year, I'm planning to. If the situation is permitted.
Yes. Okay. Hope to see you.
Okay, thank you very much.
Thank you.
Thank you, sir. Thank you so much, sir. Welcome to Bangladesh for visit, because you are very familiar and very known person, professional for BMC. You have several times visited here. I think you can, as early as possible, visit Bangladesh. Thank you, sir. Thank you so much.
Hayashi-san, thank you very much. Please visit your second home. You are in mute. You are in mute. Hayashi-san, you are in mute.
Okay. I'm so happy to talk with you, Abdul-Manan-san.
Thank you. Thank you very much.
Hello, Hayashi. How are you? Karmakar speaking.
Oh, Karmakar-san.
How are you?
Oh,
nice
I'm
to
very
see
happy.
you here.
Please open your camera.
Camera, okay. Camera is okay. Camera is open.
আমার ক্যামেরা আসতেছে না, বোধহয় হোস্ট কিছু করে রাখছে। আমি প্যানেলিস্ট হিসাবে জয়েন করার জন্য বোধহয় কিছু একটা ই থাকে সেটা আসে নাই
শুভ,
যার ফলে ক্যামেরা আসতেছে না
Dr. Karmakar,
ইয়াস
we are inviting you to join as panelist. Shubho, please allow him. Shubho, are you
Sir is
there?
being allowed. Sir is being allowed.
Please accept it. Dr. Karmakar, please accept our invitation. Thank you.
Thank you.
Yeah.
Nice to see you, Professor Hayashi, after a long time.
Yeah.
Okay.
So, Karmakar-san, are you well now?
A little bit better than before, not very well.
Okay. Yeah, very well.
Okay.
I'm so happy.
Thank
to
you.
hear
Thank
it.
you.
Yeah.
Thank you. Okay. See you next year. Okay. Thank
Yeah.
you.
Thank you. It's okay. So to finish this session. Okay. Thank you very much for joining this session.
Thank you, Professor Hayashi sir, and also Bozlu Rashid sir for conducting the session. And also I thank all the participants and speakers who have presented their talk. And again, the attendees who have joined and made this session very lively. So as most of our technical sessions are over, we are awaiting for the last technical session, which is also the closing session of ICMCS 2021. So please join us